All right, so here's a couple equations I wanted to do that we didn't get done in class. So first of all, I am going to isolate my function. Remember, we talked about that in class. You want to isolate your function first. So -1, so I get cosine of x equals 0.3. And again, there's nothing to divide both sides by because I have isolated my function. So once you isolate your function, then you just want to focus on the input here, which is x. So I'm going to use the cosine inverse to both sides. Now notice this is me. I have decided to do this. So I'm not limited by the cap, like between 0 and pi. My original function has infinite many values, and so this is my choice, but that doesn't limit my answers. So I get x because these cancel, so I get x, and then I get inverse cosine of my 0.3. All right. So now we're going to be in radians, okay? Again, if they give you like an interval of 0 to 2 pi, then you might only have a few answers that fit that. Again, you should expect 2 answers when you have just cosine x, sine x, tangent x. Sometimes you get 1, depending on if you're at 90 degrees or, in a special location. But you should expect 2 and then be surprised if you don't have 2. So you have to look at this. So you're going to undo this on your calculator. So this is a calculator problem, and make sure you are on radians because that's our intervals. So we need to be in radians. So when you undo that and you get that on your calculator gives you 1.266 radians. Right? And so again, notice your calculator is going to give you an answer in the cap because that's where it thinks you are. It thinks the original problem is this. It has no idea that that's not your original problem. And so if you think of a radian, remember that's what we did in class with trying to figure out how many radii fit around the circle with a piece of paper. So, if this is 1 radius and this is 1.2, I'm somewhere up here. Okay, so if I go the distance of, that looks like about 1.266 radiuses. So it seems like that angle, and then that length is kind of where I'm at. Okay, so when I put that radius of a little bit more than, so about 1 1/4 radius, that angle formed is 1.26 radians. All right, so that's great. That's awesome. So I can have my, x such that x equals 1 point, it's going to be approximate, 1.266 plus, and then notice 2k pi. Now, so where's my other angle at? Well, again, this has some value, which is x and y, and I am focusing on cosine, which is your x. So where else would I have the same x value? Well, x reflects over the x-axis because x is positive here, and x would also be positive down here. So I would have the same x value down here. Now my y would be the opposite of what it is up there, but my x is going to be identical, which is what I care about. Right? So I know it's over here. And so then I have to think, well, how many radians is this? And again, you can't use negatives. So you have to think, well, technically it is a negative, what is it, 1.266 radians. The problem is I can't have negatives. So, but I can realize like, oh, well, the whole distance is 2 pi, but I'm doing here. So we can just do like a coterminal angle where you can add 2 pi over and over again or subtract 2 pi over and over again. So again, on a calculator, if you take 2 pi, which is about, 6.28 approximately, and subtract that 1.266, you can get your second equation. So you have x such that x is approximately, and what did I end up getting, like 5.017 plus 2k pi. And again, the formula might have something where, k is an element of the integers, something like that. Okay. And again, if I'm limited between 0 and 2 pi, then I would sub in k equals 0. And that would give me my two answers that I have up there. So 1.266 and 5.017. And again, those are both radians and radians. If I sub in k equal 1, notice that I would be adding to pi, which would be outside of that. Now again, if I don't give you any limits on the domain, then this is your answer and you have infinite many answers. All right. The next one I want to look at in the same video is this secant problem. And it's because secants are weird, all right, because, well, lots of issues here. But just remember your inverse functions, we have some issues with those. So first of all, you want to isolate your function. So notice that's already done for you. So that's awesome. So now you're going to do the inverse secant to both sides. And if you remember, inverse secant and inverse cosecant are nice. Inverse cotangent is not nice because you have to switch to inverse cosine, and we have all sorts of lovely issues there. All right, and in fact, we might run into a little bit of them here as well. All right, so these cancel, and I get alpha of 3 equals inverse secant of 2. Okay, and so again, remember that your calculator doesn't have this key. It doesn't exist on your calculator. So again, remember how we talked about how inverse, like if this is when we were dealing with inverses. Okay, so on the side you have inverse sine, and then on the top you have inverse cosine. And remember, inverse secant goes with it because that makes sense. Those go together. And remember, inverse cosecant goes with sine. So this key is not on your calculator, but inverse cosine is. So that's the key you're going to use. But again, remember, inverse functions eat up ratios and spit out angles. So you don't, this is not a reciprocal function. It's an inverse function, but you're switching your inverse functions, which means you have to have a different ratio, because cosine is SOHCAHTOA, that's adjacent over hypotenuse. Secant is hypotenuse over adjacent. So if you switch to a different inverse function, you have to switch your ratio to be the appropriate sides that go with that ratio. All right, so now we're here. All right, so now at this point, again, you should expect two things. All right, so we're going to split this alpha in 3 and alpha over 3. All right, and remember, we do this first because that 2k pi part is going to get influenced by this as well. All right, so you're going to try to look and see, okay, when is cosine a half? All right, so let's see, there's my x. So when is my cosine a half? So it's there, which is what? Half square root of 3 over 2, which again is what? Pi over 3 up there. All right, so depends on if I want radians or if I want degrees. Let's say this time we want degrees, so I'm going to do 60 degrees, but I could do pi over 3. All right, and then my other one, again, x cosine, I'm doing cosine, so it's the mirror image over the x-axis because that's where my x is still a half. Now again, my y is negative square root of 3 over 2, but I don't really care about that because I'm focusing on cosine. And again, you can't say negative 60 degrees. That doesn't work. Even though it is down negative 60 degrees, you can't do that. So you could take 360 minus 60 to get 300. And again, we're just doing a coterminal angle. We're basically just adding 360 to that to go around to get it into a positive form, which is good. So we have that. The angles aren't consistent here, right? This angle is the reflex angle. It's really big. This one, not so much. So we need two formulas. Now, instead of 2k pi, we use 360 K and 360K because we're in degrees and not radians. And then let's see, what do we want to do at this point? Let me scroll down a little bit. Okay, so at this point we need to solve for alpha, so we're going to go ahead and triple everything. All right, so those cancel. So I get alpha such that alpha is equal to, that would be what, 180 degrees plus 0, 8 is at 1080, I hope. Okay, all right. And again, k is an element of the integers. Something like that. And then my other one, these cancel, and I get alpha such that alpha is equal to, that would be what, 900 degrees plus, and again, that should be 1080 unless I made a dumb mistake, k, and k is an element of the integers. All right, and so I should get something that looks like that. And then at this point, if you want to figure out, like if you're limited by a domain, you could sub in, you know, k equals 0, k equal 1, k equal 2, k equal 3, to figure out all the answers that fit within those domains. But we'll just assume that this one had infinite many, and we're good to go.